So in this video I'm going to discuss solution of this Codeforces round 916 related for division 3. So in this video I'm going to explain solution of first 5 problems A, B, C, D and E. Both even and E2 I will cover it. So let's now start with problem number A. The name of problem A is problem solving log. Okay. So what problem is telling us that there is a guy named Monocrap and he is given some number of problems which are in the, or I can say he has given 26 number of problems which are from A to Z, and the first and the eighth problem, I can say the A problem required 1 minute, similarly B problem required 2 minutes and C problem like 3 minutes. Okay, so now these are the minutes which are required to solve the eighth problem, or I can say ith problem. Now but the question is asking similarly that I have to tell them. So this is a log of the problem. For example, this means that the first second monograph is solving eighth problem. On the in the second monograph is solving third problem, or I can say C problem. Which means if the monograph is solving a problem at the first moment of time, which means he should be able to solve it problem, because the time to solve problem A is only 1 second. Okay, or I can say 1 unit of time, which means monograph can solve problem A easily. Similarly, you can see for B, but 2 unit of time required, and B is occurring 2 times. Similarly, he can solve B also. And for C, you can see C for to solve C, he required at least 3 unit of time, and 3 is occurring 3 times. So in this question, my monograph can solve total 3 problems. So in this problem, I have to simply tell how many problems can monograph solve if the given log is this. So I think so it is a pretty much easy problem, I can say. So but you have to tell them simply store the frequency of each and every character and check whether the frequency of that character is greater than or equal to position of that index. For example, if my current character is D, if my D is occurring more than 4 times, which means he can solve that problem, else he cannot solve that problem. So this is our problem question. So I hope so, yeah, I don't have to show his implementation because it's pretty much easy problem. So let's now begin problem number B. The name of problem B is preparing for the contest. So what problem is telling us that there's a monograph and there is some sequence of problem which is given to us. But if monograph solve a problem of higher rating than previous one. For example, previously let's suppose monograph solve the problem of rating number x. Okay. Now monograph solve a rating problem of rating x plus one. Then the monograph get excited. Okay. So what problem we are simply asking us that they will be given some n number problem, and I have to give them a sequence in which monograph can be excited k times. Okay. So how to solve this problem? It is pretty much easy. For example, if my k is 3, which means monograph is getting excited k times, and my n is 6, which means total there are 6 number of problems. So how to excite monograph 3 number of times? So there is a sequence. So I will write this number. So so I will simply write this number in a certain sequence. For example, how to excite a monograph? I can simply write it like here. For example, let me write here 1, and I can write another 4 and 5 and 6. Okay, and the remaining number in the decreasing order, like 3 and 4. So how many times that my next number is greater than my previous number? It is 3 times. 1 and 4, 4 and 5, and 5 and 6. So monograph is getting excited at most 3 number, at getting excited exactly k number of times. So in this case it is happy. So how this problem solving? How to solve this problem? First of all, check the k. Okay, now find the n minus k. For example, in this case it's 6 minus 3 plus 1. Okay, so it is 4. I know. So now write the counting from 4 to n in the increasing order, like 4, 5, 6. The remaining number in the decreasing order from my first number, like 2, 3, and 1. It is a problem. So this is a pattern which you have to fit for any certain k. So I have so you have understood problem number B also. So let's now begin problem number C. So it is a pretty much greedy problem, I can say. Most of you can be thinking of a deeper problem because I can check every other way. So first of all, let's unroll problem statement. The name of problem C is quest. So what problem is asking? There's a guy named Monograph again. He's playing a let me boil down the question easily. For example, I have given two number of arrays, array A and array B. Okay. In a single operation, monograph can take in a first operation, monograph can only take the first number from my eighth, eighth array. Okay. Now if monograph has taken a number from the eighth array, now he has two options. Whether he can choose this array again or I can say this index again so that my sum now if monograph choose that number again but again but if he is choosing that number again that time my a of 0 will not be added in my answer. Instead my b of 0 will be added in my answer. Okay, which means if I am performing two operation, in the first operation I have to choose 4 only. I cannot choose b directly, right? Because you see this is a starting point for this ith index. So you see, if I choose the fourth index, I will choose a 4. Okay, zero index I will choose a 4. But if I again try to perform operation by zero index, I will choose the b of 0, which means in the two operation I am getting sum as 5. Okay, now if I want to go further, if I want to go further, the all the number which are previous to that index should be taken. For example, if I want to pick this second index or I can say third index, then my these two index should be picked, or I can say these two index should be picked already. Okay, my these two index should be picked already. Then I can only pick this index. Or if I'm picking this index, then I have three options left. Whether I can choose again this number, and this number. So I have to maximize the score and tell them what is the maximum score which I can get by performing some number of options in a certain way. So how to solve this problem? I think so this problem pretty much easy, but why so? So let me take example here. So this is my array number A, which means if I am performing the first operation on my I index, I will choose number among these only. But if I want to choose another operation on the same index, then I will choose a number like 1, 1. Let me take another example, a big one. Here it is like 2, 3, 4, 1, 4. This is a index which I'm picking the first time. But if I want to pick the second time, then I will choose like 2, 3, 1, and it is 4, and here it is 7. Okay, right. So now tell me how to perform operation. So I simply run greedy approach. How greedy? At every moment, I'm going at most to the ith position only. Okay, let me repeat again. For example, this is my number of position. So for each and every position, I will check. In my final answer, at most I will go to at this position. I will never go further from this next, which means I will never interfere in this index. I will only deal with these indexes only. Okay, so this is my greedy approach. So how to approach now? First of all, how many operation I have? In this case, I have total 5 number of operation. Okay, so let's suppose if I want to go to till this index only, to this index only. So what is my maximum score? I will not interfere in this array. Okay, I will only dealing in this subarray. This array I can say. So first in the first operation I have to choose 3, right? How many operations I'm left? I'm left with 4 more operations. So now you can say, what are the other operation which I can perform? I cannot take 3 again. The operation I'm left with only is this 2 only. So I will to pick the 2 4 times. This is my sum for the ith index. Okay. Now what if I want to increase my search space? If I want to increase my search space, which means I will not interfere in this part. I will only deal in this part only. Okay. So if I want to come at max this position, okay. If I want to come to at max this position, what is my sum minimum sum which I could have? So if I want to come at this position, in my answer 3 and 2 will always be there, right? So I will simply add 3 plus 2, and my number of operations left are 3. Okay. Now you see I am having 2 more operations left. whether I can choose these two, okay, or I can choose these three. So which number I should pick? Greedily, you can see I will always pick the maximum number, which is 3 only, right? So I will simply pick the maximum number, which is 3, and how many operations I have left? I am left with 3 operations. So I will simply pick 3 times. So this is the answer for index number 2. Now let's change my search space. Okay. So if I want to, I will not interfere in this part. I will only deal to at most this part only. So if I'm coming at this position, what is my minimum score? So in my minimum score, 3, 2, and 4 will be there, which means is in my minimum index, my 3 plus 2 plus 4 will always be there. Now what are the remaining operation? My remaining operation are 2. Okay. So if my remaining operation are 2, and number of operation which I can perform is these 3 only. And so now tell me, I will always choose greatly maximum number, which is 3 again. So I will simply add 3, and how many number of operation I have left? That is 2 only. So I hope so till here you have understood the problem intuition. How to solve problem number C. So it is a pretty much greedy. So let me repeat it again. So till every point I will check. If at most I will came to this position only. I will not change. I will not pick any number beyond this index. Okay. So to come at this position, what is the minimum score which I could have? That is the sum of AI, all the number of AIs. Okay. I will simply add them. So what are now I will calculate the remaining operations. Okay. So what are the remaining operation? Index minus number of operation I perform. For example, in this case, you can say my I is 3. I will simply minus 3, and number of operation left are 2. So if I am remaining with 2 number of operation, and the my and these two operation these two operation I can perform on which indexes? I can only perform these two operation on the bth array. So I will try to maximize score. So I will choose a maximum till my current index and multiplied remaining operation by that number. So if I show you this code, the code is pretty much easy. First of all, I'm taking just the input of both array A and B. Now I'm calculating my sum, which is sum till the ith point. Here you can see my sum till the ith point. If I am picking the ith point, which means I'm also performing operation, right? I'm also performing operation. Now tell me, if I'm performing operation, what I will also calculate the maximum bi till ith index. Okay. Now what is my answer? My answer is simply sum, which means the sum of all these numbers. Okay. My sum plus maximum, which is maximum of bi multiplied by remaining operation. Maximum of bi multiplied by remaining operation. And at every point, what is and at every point I will check the my maximum value and print that in the end. So this is whole problem intuition problem number C. So let's now begin to problem number D. So this problem number D. The name of problem D is 3 activities. Okay. So what problem is telling that there's a guy named Monograph again. So he has to go on 3 activities. Either it will be skiing or watching movie or play board games. Now what they have said that on the ith day AI friends will join him for skiing, BI friends will join him from movie, and CI friends will join him for playing board games. Now what he asking us to do that he cannot perform 3 activities or 2 activities in a single day, which means either he can call AI friends to have skiing, or he can call BI friends for movie, and similarly for CI also. Now you tell me how many number. Now he also has a condition that at the end of the all the holidays he want to maximize the friends which he have played with, which means he have to maximize the value of ax, by, and cz. And you see, none of my index can be same because he can only play a single game in a single day. Okay, so how to approach this problem? So maybe you could say that it is a sorting or a greedy problem or a implementation type problem, but I have solved this problem using a bitwise and a dp, or I can say dp only for a because bitwise is simple syntactical sugar on that. So simply I will tell you how to solve this problem using DB. Okay, so let's suppose this is my case. For example, if my first array is like that, so this is my first test case. So at every point I will mark three numbers which will be initially 0. Okay, so at every point, so for example, if I'm on this index, so initially my all the numbers are 0, right? So if my all the numbers is 0, I will try to pick all the numbers. For example, my first case is like this. I will try to pick my I will try to pick my case which is on the this form, which means I will simply add 1 and pass a number like next index, which is I plus 1. This is the DP state. Now you see, if this is my original configuration, then my configuration, how would my configuration would look like? 0 means the eighth index, or this means the bth index, and this means the cth array. So if I'm picking an element from the eighth array, which means I have utilized I have utilized that operation, which means I will simply pass it here 1 and other are zeros. Okay. Now now rest of the array also. But if now you see, at the zeroth index my b also 0, which means I can also add a b. I will also add a b. Now I will simply pass on I plus 1. But now you can see, if I am choosing operation from the bth array, then I will simply pass on 1 to the bth array, which means my initially a will be 0 and here it will be 1 and here it will be 0. Because you see, I cannot take two operation on a single day, which means I cannot send it like 1 1 0. This means I am also performing activity A and B on the same day, which is not possible. Okay, so this is the case, and the last case is like C, which means 1 plus I plus 1 comma 0 0 1. This means I have performed the operation on the cth day or in the last day, or I can say I have performed the activity on this day. But there is one more case. If I'm calling no friends, if I'm calling no friends, then I will simply pass on the function simply to this only, like 0 0 and 0 only. Okay, so you see, this is a bitwise only, or I can say this is a mask only. You can simply create a mask of you can simply create a mask of size 3. Okay, and you can easily access the all the three numbers. If at any point my first value is 0, which means my first value is 0, which represents that I can take a operation or I can perform a operation on the cth array, or I can say I can call a friend for the cth game. Then if I want to call the game if I want to call the friend for the cth game, then I will add on this number in my answer and pass it 1 instead of this, and similarly the rest of the configuration as it is only. So if I show you this code, the code is also easy. I'm taking the input of in the all three arrays. Then what I'm simply maintaining a mask in my dp states. So you see, if at every point I'm having the some number of possible conditions. First condition is like that I am not picking any of the number. If I'm not picking any of the number, I will straight away pass the mask as it is, which I have received from the previous value. Okay. But if you see, if my zeroth position is empty, which means if my zeroth position is empty, I can choose my eighth array, which means I can choose operation from this array. Okay, I will simply mark it as visited, because you see, if my initial mask is like 0 0 0, then by choosing a value from the eighth array, I will simply mark it as 0 0 1, so that in the near future I will never take again this value, or I will never take a value from the this ports. Okay, so I will simply mark it as visited and simply pass on array of I comma I plus 1 and updated mask, and similarly all the remaining values. But for the next call, I have to I have to reassign my mask to 0 0 0 only, because you see, if I want to perform the operation on the B part, then I have to make like 0 1 0. I cannot simply attain this change. This will be wrong case. So I will simply make my mask as an original mask. Then check if my second position is vacant, which means I can choose an operation from this index. If I can choose a operation from that index, I will simply choose that point and simply add in my answer and pass on the updated mask after making this position as 1. And for similarly for the last case, if my this position vacant, I can make it like 1 0 0, and you see I will simply pass on the function by passing on a of c of I in my final answer. And what will be the and maximum of all these cases will be my final answer. And what is the time complexity? So you see the mask of three values which means 0 0 0, it is at most 8 only. So my complexity is 8 into n, which is hardly giving me TLE. So similarly, you see, I'm getting a DP of 8 comma n and assigning it here. If at any point, if my state is already visited, I will simply pass on that only. And this is our problem, tuition problem ready. So I hope so. Most of you may be thinking of a sorting algorithm type problem, but it is not. It is a first sort DP problem only. But there could be a implementation of sorting also. But I have implemented from DP only because this is the first thing which strike to my mind, and this is it. So now let's begin problem number E. So I have solved only problem number E2, which is a harder version. I have haven't seen the problem number E1. So let me tell you how to solve problem number E. So first of all, let me tell you what is problem number E2. So there are two players, Alice and Bob, and initially they are given some number of marbles, which means the and there is a color assigned to the each marble, which means Alice is having AI marbles of the ith color, or I can say A1 marbles of the color number 1, A2 marbles of color number 2, similarly N marbles of color number N. And similarly Bob is having B1 marble from for color number 1, similarly B2 marbles for color number 2. Okay, now they are playing a game. How is the game played? So game is played in such a way that first of all game is started by allies. Okay, now what they are doing? They are choosing a single index. Okay, they are choosing an index, and what they are doing? They are simply decreasing one value from their marble and picking up all the marbles from their opponent. Here you can see picking one marble for their color and discarding all the marbles of the opponent. Similarly, you can see, but if my game ends, if my so you see this is a tricky statement. The game ends when there is no such color I, when there is no color I, such that both the player have at least one marble of that color. Let me repeat it again, which means if at any point my both of the marbles, my all because you see if at any point there is no pair left where my marble of AI and marble of BI both are greater than 0, then my game can continue. But if at every point there is 1 0 in either A or in either B at every index, then my game ends. Now what they are saying, there is a value score. What is a value? The value score is simply sum of the marble of A minus sum of the marble of B. Now Elias want to maximize the score and Bob want to minimize the score, which means Elias want to maximize the marble which he is collecting, and Bob's want to maximize the marble which Bob is collecting. If both of pair play optimally, now tell me what is the score at the end of the game. Okay, so I will simply tell you the intuition of this problem. Okay, so let's suppose I'm picking up this test case. It is 120 and it is 120 20 again and another 100 and 15 and 10 and 20. Okay, now Bob want to maximize the value and Rice want to minimize the value. So first of all, I will calculate the sum of AI and BI. I will calculate the sum of AI and BI. I tell you later why I am doing this. So here it is 101 and here it is 35 and here it is 11 and here it is 40. Okay, now I will sort this array in a decreasing order. Okay, I will sort this array in the decreasing order. Similarly, it will be like 101 and here it is like 40 and here it is like 35 and here it is like 35 and here it is 11. So what are the corresponding indexes? it was 0. It was at the 0th index 1, 2 and 3. And here you can see my 0101 is at my 0 index again. My 40 is at here, my 35 is here, and 1 is my here. Okay. Now I have sorted the value according to their sum of AI and BI. Now in a single operation, what LIs can do? LIs simply want to maximize the scores. Maximize his score and minimize the score of BI. And okay, so there's a simple case, but there's also condition. If I'm performing an operation on this index, I will never perform operation on this index again. Because you see, if either Bob uses the operation on this index, my one of the value becomes 0. If my Bob is performing operation, then my value is like 0 comma 1. But if on this I am telling on the 0th index, but if my Alice is performing operation on the 0th index, then this value become 1 0 comma 100. In short, I am telling at most I can perform an operation only. Okay, because you see at every point my one values become 0. Okay, now when will my game end? My game will end when when at every moment of time there is at least one zero among A or among B. So you see, I can at most perform an operation only. So this is the condition. Now how to maximize score? So if I want to maximize score, the first turn is always of Elias. So Elias want to maximize his score. So which means Elias is at this position. So he will choose a AI AI's value of this index, which is 0 index, which means he will add 1. Okay. Mm, okay. So let me repeat it again. The question: what is the value of score? So the score of the game is difference between the number of remaining marble of Elias and Bob, and how they are collecting. After some discussion, they come of idea on the turn that both the player have at least one marble of that color, and the player is discarding the one marble of the ice color, and the opponent is discarding all the marbles. So okay. Now let's suppose if my so this was the test case. Okay. So now how is the operation performing? Elias is performing a single operation, which means he will choose the AH value on the 0th index. Okay. Now this value is discarded, which means if Elias is performing a operation on this index, then this value become equal to 0. Okay. Now which means I cannot perform an operation on this index. Now next. Okay. At this 3. Now there's a turn of Bob. So what Bob is doing? Bob is simply subtracting its value. So if we subtract the third value, which is 40, and here it is 20, which means he will subtract 20 from the answer. Okay, if I'm performing operation these text, which means I cannot perform further, which means I cannot perform further operations. Okay, now if now at index one, now if I'm at index one, which means Bob can Elias can Elias can perform operation on my AH index, which means he can add 20. Okay, he will add 20. Now next turn is Bob. Now where Bob will perform operation? Bob will perform operation on the second index. Now if Bob is performing operation on second index, he will subtract minus 10, which is its value minus 10. Now the sum of all these values is minus 9 only, which means the score is minus 9 if both are playing optimally. Here you can see the answer is minus 9. Okay, let me debug one more test case. Because you see, I have to always to greedy approach, because if I'm performing a operation on a single index, I cannot perform operation again on that index. Right, it is right. Now what is the answer for this test case? Let me take it again. So this is test case. So how to perform operation? First of all, I will calculate the sum of all these values. Here you can see it is like 12 and 6 and 11 and again 11 and again 7 and 10. Now I will sort these values. First of all, I will write the index like 0, 1, 2, 3, 4 and 5. Now I will sort the values according to their sum. How to sort these values? Similarly, the largest value is 12 only. So I will write 12. Okay, the index is 0. Now next value is 11. So I will write it in index 2. Next value is again next value is again 11. I will write it in index 3 also. Okay. Now next value is 10. 10. I will write it in index. Okay. Now next value is 7. I will write it in index. And my last value is 6. Now its index is 1. So this is my array looking like. I will erase this part. Now how to perform operation. So if my first turn is of Elias, he will go at the zeroth index and add this sum, which means he will simply add 3 in its answer. Okay, now this value is gone. I cannot perform operation again. Now my next value is 2 and it is a turn of now it is a turn of Bob, which means he will choose the operation on this. Which means he will choose the operation from this and subtract -7. Okay, and subtract -7. Okay, now the turn of Elias again. Now he will choose a operation from third index. From third index he will choose 2 and subtract and add 2 here. Okay. Now next turn from above at index 5. So at index 5 0 1 2 3 4 5. This position. From this position he will subtract his answer. Okay. Now at this position 4. At 4 it will Elias with L is answer. Okay, plus 5. Now last turn is of Bob again at 1, which means he will subtract -4, which means at every point my one of the values is become 0, which means I cannot perform further operation. Now what is my answer? The answer of all this my answer, which is again you can compute, which it will come into it will come -6 only. So this is approach of problem number 8. So how to come up to this approach? Because you see at every point Elias want to maximize his sum and Bob want to Elias want to maximize his sum and Bob want to minimize its sum, which means I will always try to pick the maximum value for the Eli's case and minimum value which Eli's can take for its. So I will take that value. So the sum of all the corresponding values is my answer. So if you have any doubts in all these problems, you can comment me down. Till then, stay tuned for the next one. Thank you.